Yeah, good morning everyone. So today we have the first class on current affairs compilation classes. So today we are going to discuss about different types of ISRO launches. So what we have been doing so far in current affairs? Give me a broad picture. Yeah, first we have Saturday classes, 5 to 7 and all. Here what we are doing? We are basically doing 30 questions from monthly basis, roughly monthly basis. So far we have covered from April 2022 to September. Now after the Holy Week, we will continue this from September, October, November till recent times. This we have been doing in Saturday classes. This was our first program. Second, what we have done, this current edge test series we have. इसमें दो component था. One, you have to give the exam, so you have some practice. Secondly, we have so far released 6 workbooks. Every workbook will be having 25-30 pages. So what was the purpose of this? This will act as your personalized set of notes. So the objective is one, you have to over the time develop this personalized set of notes. Then you have to have some practice of giving the exam and all. Now this is the third part of it. This is like something like a revision classes. Here our objective is to not talk too much on basics or not in a detailed way. We'll try to finish every topic as far as possible and we'll keep the horizontal coverage broad. And these we are doing in team wise. Like first we are starting with science and tech. From science and tech we have today different launches of ISRO, then different satellite orbits, then what, ISRO missions, programs, then global missions, then astronomy, observatory related developments. These are 5-6 themes which we are going to cover today. After this we will do science and tech mein defense karega. Then I told emerging technologies will be there. Then at last healthcare and biotech aspect will be there. Here we will try to include some NCERT also, because we have seen so many PYQs last week. We have seen so many biology questions. You have to have some conceptual clarity. So this is the overall objective for science and tech. Get started. Yeah, so first start with ISRO. What is objective of ISRO? Indian Space Research Organization. Development and application of space technology for different national needs. National needs can include from citizens' needs, government's needs, military needs, everything. So this is basic objective of ISRO. Under which ministry it is? No ministry. Any other opinion? ISRO is under, absolutely correct, ISRO is under Department of Space, which is directly under Prime Minister. It is not coming under Ministry of Science and Tech or any other ministry. It is directly under Prime Minister. This is cited as one of the major reasons for widespread success of ISRO in recent times. There is least interference, the fund transfer, everything, allocation, everything happen in much faster way. If ministry is there, there is higher bureaucratic process. Where is the bark and all? What is headquarters of ISRO? Bangalore. This is also cited as one reason because it is down south. If it is in New Delhi, there will have been no bureaucratic interference, and something it is in Bangalore, it is more acting like a totally independent. It is having true independence in its functions. So other basic things, it was started in which year? August 15, 1969. Before that we have a INCOSPER as the preceding organization. Now the works of Sir Vikram Sarabhai, that was led to the formation of ISRO. Go ahead, rest details you can read about it. So what are the major launches means what? Launches are not missions. Launches are like rockets that takes the satellite into orbit. So which are the different launches ISRO is having? There has been previous launches also which we are not covering, that has been decommissioned right now. Today we have PSLV. This is Polar Satellite Launch Vehicle. Which one is the most reliable launch vehicle of ISRO? GSLV or PSLV? It's not GSLV, it's PSLV. This is called workhorse of, we'll see in the next slide, workhorse of ISRO. It is having a efficiency like success rate of around 94-95%. So this is one of the most reliable program of ISRO. Second, we have Geosynchronous Satellite Launch Vehicle, GSLV. Then we have Geosynchronous LMV-3 vehicle, Mark 3 vehicle, launch vehicle, Mark 3 vehicle. Then what is sounding rockets, we will see in the slides. Then some recently developing technologies we have. Human LMV vehicle, this is same vehicle which is used in Gaganyaan mission. So for Gaganyaan mission, that is humans are taking into space. So we are adapting this vehicle to customizing it to serve the different human related aspects of it. Now small satellite launch vehicle is recently released. I told in previous class also. Around February 10, we have the first successful launch of SSLV, first successful launch. There was previous attempt made in August 2022, but that was failure. This was the first successful launch of SSLV. Now reusable vehicles are being tested. Scramjet engine is being recently tested. So all this, that is the basics of Scramjet engine. With that we will see. That is the purpose of this lecture. Go ahead. So what is PSLV? Polar Satellite Launch Vehicle. I already told this is workhorse of ISRO because of its huge number of, recently if you look, when this GSLV technology matured, only in 2014-15 after this GSLV started maturing. Before that, so many GSLV missions have been going failure. But PSLV has, overall these years, it has been consistently performing. Out of 55 around missions, 50 to 53 missions have been successful of these PSLV launches. Now what is its capacity? How much it can take? We have the sun synchronous orbit. What orbit it is? What does it basically mean? There is a sun-earth axis, the angle with this axis will be same. What advantage it gives? There is earth, there is sun, there is some light. This angle will remains always same. So advantage is it is around the same local time, it will pass over same location. Suppose we are in Delhi, some sun synchronous satellite is passing over Delhi. Now at least same local time it will be passing over Delhi every day. What advantage it gives? Like if you want to like vegetation of a space, like light, that is sun time will be exactly same. Sun time exactly same means how much light is falling over the place, how much light is reflected. So over the time if you want to observe a place, this is one of the best. SSLV or sun synchronous orbit is one of the best orbits. Now what height it is? Around 600 kilometers. And PSLV can take up to 1750 kg payload into sun synchronous orbit. What else? GTO, what is GTO orbit? Geosynchronous or geostationary transfer orbit. What does that mean? Yes, yes. Geosynchronous basically what height it comes? Geosynchronous and geostationary satellites. 35,700 something kilometers. It will be at this much of height, means huge height. To this much height, it can carry 1425 kg of payload. Now geotransfer orbit means you placing it in this much height. Then if it is a moon mission, you slowly shift into orbit of moon. So this shifting orbits will be like continuous orbits. These orbits are called geostationary transfer orbits. So this is the capacity of PSLV. What else? It is a 4-stage engine. 4-stage engine means it will have 4 different motors or 4 different propulsion systems. And the first one is solid, liquid, solid, liquid. And why we are using solid? Most of the launch vehicles, you will see the first stage will be solid stage, because it is that at that stage you need maximum thrust to lift the vehicle, and the weight of the vehicle will also be very max at this point. So due to this reason, at most of the launch vehicles you will see that the first stage will be solid stage, solid state propulsion, then liquid, then solid. It's a 4-stage vehicle. It is famously used in Chandrayaan-1 mission, Mars orbiter mission in 2023. Go ahead. Now what is GSLV? GSLV is much powerful than PSLV. That is a differentiating character. What we have seen in PSLV is it's reliable, but it only can take 1000 something kilograms into this 600 kilometer orbit. GSLV is much more powerful than PSLV system. How much it can carry? It can carry 2252 geotransfer orbit. Then if it is a low Earth orbit, it can carry up to 6000 kilogram of payload. That's a significant payload. And don't come with this assumption that GSLV is used for geostationary satellites only. There is no such differentiation. All the satellites can be used for any XYZ applications. GSLV can be also used for low Earth orbit applications. It can carry much higher payload of 6000 kilogram. Differentiating aspect is power. Major differentiating aspect is power. Here it is having 3-stage propulsion system. And the first stage will be solid, next stage will be liquid, and there is upper cryogenic stage also. We will see details of the cryogenic stage. Go ahead. So let's see what is the major differences between liquid stage and solid stage propulsion. What does it mean? In solid stage propulsion, we use a mixture of powdered aluminum and metal oxide as fuel and metal, and this will be ignited, and this will be act as the fuel oxidizer mixture. Whereas in liquid stage, what is the fuel? Either it can be hydrocarbon, like kerosene type of hydrocarbon, or it can be liquid hydrogen also if there is cryogenics in play. Oxidizer means it's like metal oxide is itself acting as oxidizer in solid fuels. Here we have to keep a separate tank of oxidizer. Oxygen will be carried in a separate tank, and this will be mixed in the combustion chamber. Now combustion also has some specialities. If you start the solid state combustion, it is not possible to control it or not possible to stop it. Is it started meaning started and it will completely burn out and then it will stop. But in liquid stage, you can regulate it. How much thrust you can generate, how much all these different aspects of combustion, you can have much more control in liquid stage propulsion system. Now thrust, I already told. What is thrust? Upward force that is generated. Now it is much greater in solid stage propulsion. That's why we are using this in first stage of most of these launch vehicles. Here the thrust will be little less. Solid, what else? Control we already told. Cost is, this is generally design variables are much less. So this is a little bit easy to design. Here the design variable, you have better control, but the design variables are too much. So you need more sophisticated systems, so cost will increase obviously. Reusability, this cannot be reused. Once it burn out completely. Here there are systems you can reuse these liquid stage launch vehicles again for second launch also, after some refurbishment and all. So this is major differences between solid stage and liquid stage propulsion. Go ahead. What is cryogenic propulsion? Is it a part of solid stage or liquid stage? It is part of liquid stage compulsion. What is the speciality of this? Why we are using this? Where we are using this? All GSLV third stage, uppermost stage of the GSLV propulsion is cryogenic propulsion. What does it mean? Yes. We have in liquid stage propulsion, what you have told, we have separate tank for fuel as well as oxidizer. Now, if you use liquid, what is the advantages of keeping this fuel and oxidizer as liquid? Tell me. If you are carrying hydrogen, if you are carrying hydrogen in solid form, you need very high pressure system to contain this hydrogen. You need a tank which can withstand very high pressure so that you can compress so much of hydrogen and carry it as a fuel. Weight will be similar now. If you want to burn this much of hydrogen, amount of hydrogen you have to burn will be similar. Difference is like the system to carry this hydrogen. That is, if hydrogen is carried as a gas, if you have to carry a gas, what is the peculiarity it will be having? It should be compressed to a very high pressure, and this high pressure system you have to carry. Same goes with oxygen also. Now, once you are keeping it as a liquid, then this high pressure requirement is not there. Liquid means there will be normal pressure, you can carry this. But to get this fuels as liquid, you have to cool it to minus 253 degrees for hydrogen and minus 183 degrees for oxygen. So what is difficulty in this? One is you are keeping this inside a propulsion system where the temperature is too high in the combustion chamber, as well as the atmospheric temperature is too high. So you need a very solid insulation system so that this tank will remain. Secondly, when this fuel has to be used, you need to pump this fuel at this temperature into combustion chamber. This pumping process, the whole process should also remain within this temperature. So you need design a pumping system which work at these extremely low temperatures. So what advantage you will get? One thing, you don't have to handle with extreme pressure. Second advantage is this is considered as most efficient and provide much higher thrust for per kilogram of fuel you are carrying. So for this purpose, on all these upper stage rockets, which either will be doing this, going to other planets and all, will have, not just of India, other countries also will be having this cryogenics technology. Now, cryogenics is a broader technology. It's not just limited to propulsion. It is anything which you preserve this XYZ chemicals at this temperature, we call it as cryogenics technology. Here we are talking about its application in this propulsion system. Go ahead, rest you can read about it. Liquid oxygen or liquid hydrogen, all these aspects are given. These are all exactly taken from this ISRO website. So all these details are directly screenshot from this ISRO website, so that if you are reading this material, you will have a comprehensive knowledge from the primary source itself. That is the objective. Go ahead. What is POEM platform? This was recently in news. I think we discussed in class also. Tell me what it is. Remember? If you are watching online, tell me. Comment karo, what is POEM platform? What is it like? PSLV, how many stages it has? 4 stages. First stage is solid, liquid, solid, then again liquid. So how this rocket will be designed? Look at the design system of this rocket. How it will be designed? It will be having a lower part. Then first this part will be having the first stage, solid fuels, combustion system. This will burn out, then this part will removed, then only this much part will be left. When second stage of propulsion or combustion start, this part will start combustion, and this part after completion of this will be removed. Now we reach this much, and satellite will be at the top of the rocket. This is the basic design. So what you can see is this will be at lower altitude. This also will be at lower altitudes. But higher stages like fourth stage was also all this combustion part are being burned and lost. And this is happening at a much higher altitude. So can we put some more other system with these rockets so that when the rocket is burned and lost, this also will be going into at the higher orbit at some required orbit. Understanding? Usually rockets has only one purpose, take these satellites there, and what all other system is there, they will be burned out. So in point platform means if this will not be that much effective, if you put some XYZ things here, payload here, then it will be put, means it will be at very low orbit, so you cannot that much use it. But at least in fourth stage, that is happening at a much higher orbit, you can place some other payload with this rocket system itself, so that when the rocket is burned out, this will also be put in some XYZ required orbit. So you have capacity to take more number of satellites. This system is called POEM platform. What is the PSLV orbital experimental module? That is the full form of the POEM platform. This has been recently tested by ISRO. It is only done in PSLV right now. Later it will be expanded into other launch vehicles also. What else you have to learn? Discarded part of these rockets will also carry some kind of XYZ payloads. That is the basic idea of POEM platform. Here these are different steps, lift from this place, separation of each part is getting separated at different heights. At this last stage it will have two components, one will be the satellite and the other one will be this XYZ, that payload we keep with this rocket. This will be mostly what? Mostly it will be something like sensors, something imagery equipments for remote sensing applications, this kind of application, or some temperature sensors, something like that. Not very sophisticated material because this is being tested for the first time. Go ahead. Otherwise everything get burn out except this satellite. Everything part of this rocket system will burn out, and at the end stage this satellite will reach XYZ position. At this position whole system will burn out. So we say that the satellite has been put in the XYZ right orbit. If any XYZ millimeter difference is there, sometimes satellite go into some other orbit, that will completely crash the system. Either it will come into atmosphere and burn out, or it will not place in the orbit which you can communicate with the satellite. Space debris, these all are in atmosphere itself. These all mostly burn out in the atmosphere, or it will come out in the atmosphere itself. This will not that much act as space debris. Only in the uppermost stage it can act as space debris. Go ahead. Now we discussed about PSLV, GSLV. Now next we have to see Launch Vehicle Mark III or GSLV Mark III. What is specialty of this vehicle? This is a advanced GSLV vehicle. It has 3 stages. All these systems are very much similar. It has solid stage at the first level, then liquid stage, then it will be having a cryogenic upper stage. What is speciality of this? This is India's most powerful rocket vehicle that India is having. It is right now called LMV3. Gaganyaan mission is also using this same rocket itself. What is its capacity? It can take 4000 kg to geotransfer orbit, or it can take up to 8000 kg to low Earth orbit. Go ahead. Rest all the things which you have seen in GSLV will be more or less applicable here. This is like an adaptation of GSLV system. Launch Vehicle Mark III. What is a Vigas engine? We have told that it will having solid stage propulsion, then liquid stage propulsion. This liquid engine is called Vigas engine. So all the system inside liquid part will be having a Vigas engine inside this. Now what is small state launch vehicle? SSLV. Why we are designing SSLV? Why we are going into SSLV phase? Space industry itself is seeing advent of commercialization, privatization, and all. Private sectors is coming into space sector. Now the demand for number of launches is going to be much higher. Now ISRO work with a closed system where there is huge turnaround time for PSLV and GSLV. Number of launches it can do is very limited. So we need a system which can take up orders on demand and put satellites in XYZ orbit, which have very less turnaround time. Turnaround time is very less, and on demand you can make this. So to meet this XYZ demand, this SSLV came into existence. What are the specifications of this rocket system? It is a 3-stage solid propulsion system. All stages are solid. There is a liquid module as terminal stage, but technically all stage is solid propulsion itself. What else? What is the capacity? It is basically for nano, micro, mini satellites. It has a capacity of 500 kg to be launched into 500 kilometer orbit. क्या कर रहे हो? Off कर रहे हो? Okay. So recently in February 10 we launched this Earth Observation Satellite 7, then Janus 1 and Azadi Sat. These are like nano satellites. These 3 satellites has been put by SSLV, first successful program of SSLV. Go ahead, launch on demand basis. That is a peculiar characteristics of SSLV launch system. Go ahead. Now what is this? Reusable launch vehicle, RLV, technology demonstrator that has been done. This is not commercially used. SSLV is commercially used for launching XYZ vehicles. This is only all this. Next we are speaking about Ramjet and Scramjet. That is also not commercially used, but there has been serious tests done on reusable vehicle. What is specialty of this? Majorly this cryogenic systems and this liquid stage propulsion system, this will come back and you can use it for multiple launches. Integrated flight management, thermal protection system. These are different systems where we compulsorily need this in designing, in programming of Gaganyaan mission. These are all associated with Gaganyaan mission. Why? We have seen these photos of PSLV, GSLV. What extra Gaganyaan mission will have? We have this kind of a rockets. At the top of it, we told there will be satellites. At this point, instead of satellite, there will be a flight. There will be like something in the shape of an aeroplane. This will be acting as satellite for some time. Then it will do the number of days, 3 days or 4 days, that rotate around the Earth. They will do the experiments. After that, this has to come into Earth as flight or some kind of system. It has to come back into Earth. So it is in this context, this reusable technology is much more important. Go ahead. Gaganyaan mission we will see in detail in upcoming slides. Now what is Scramjet engine? Instead of wasting money on taking the oxidizer to that elevation, we will use the... Exactly. This is called air breathing propulsion. In all the engines we have discussed so far, we have been saying we have, if it is a liquid stage propulsion, we have 2 tanks. One will be having fuel, other will be having oxidizer. Oxidizer is mostly oxygen itself. And how much is nearly 70% of this weight is oxidizer itself. 70% of weight of fuel oxidizer mixture you are carrying is oxidizer. That means this is a very considerable weight. Now what this scramjet or ramjet engine does is, instead of taking this oxidizer with the rocket, it will take this oxidizer from atmosphere. Okay, that's why it is called air breathing engines. Only fuel will be part of the rocket system. From atmosphere it will be taking this oxidizer. What else? Utilize atmospheric oxygen. This will be reusable technology. Cost of launching will considerably come down. How cost will come down? One thing, the weight of the rocket will considerably fall. 70% you don't have to carry. So you need to carry less weightage, and you don't need to have the sophistication for oxidizer and all. So cost will come down. It will be reusable technology. So that is also an advantage. And there are different 3 variants of the system. One is ramjet, then scramjet, then dual mode ramjet. What is difference between these 3? First start with ramjet engine. What is ramjet engine? How this will work? This engine we have talked. Suppose our rocket is going like this. Now this will be the top part of this rocket, and there will be some opening here. It is through this opening the atmospheric air will be entering the rocket. Now can this air be used for propulsion or combustion? What is XYZ we will need? This will be at low pressure. It will be at higher heights. With heights, pressure considerably drops. This will be at considerably low pressure. And if it is in top of the stratosphere, troposphere and all, temperature will also be negative temperatures, very less. So low temperature, low pressure gas, if you are coming in, it's of no use. So what is our requirement? We need to compress this air into higher temperature and higher pressure so that it can be used for combustion. Now in ramjet, scramjet, how it is combusted? We pass it through a combustion nozzle, XYZ nozzle. The shape of the nozzle will be such that when the air is entering the area, if it is a ramjet, means combustion happens at up to Mach 3 speeds. Less than supersonic speeds, less speeds, it is called ramjet engine. Like this combustion happen at non-supersonic levels, that type of engine is called ramjet engine. Combustion means the burning of this atmospheric and fuel happens at non-supersonic speeds. Non-supersonic means Mach number is less than 1. At this level, if combustion is happening, it is called ramjet engine, and this is best operated at around Mach 3. Now if you need much higher temperature, you need the combustion to happen at supersonic speeds. Then it can work efficiently up to Mach 6 and all. So this combustion is called scramjet engine. What is the difference? Technology all is same. Combustion will be happening at different speeds, and depending on this speed ranges, the shape of the nozzle will be changing. If it is a ramjet engine, we will design nozzle like area is continuously reducing, something like this, a funnel like shape. So funnel like shape, if something is coming, area is reducing, pressure will increase, it will act as a compression, and this compression will take the oxidizer into a required level for combustion to happen in the combustion chamber. Here the shape of the nozzle will be completely different. Here the shape of the nozzle will be, it has to handle shock waves, because all this process, all the flow of XYZ inside this will be happening at supersonic, hypersupersonic speeds. The systems of scramjet is used for hypersonic engines like Mach 6 and all. Got the basics? Dual mode means what? At Mach 3 it is ramjet is best. At Mach 6 ramjet or scramjet is the best. Dual mode means at lower speed it will act as a ramjet engine. At higher speed the nozzle shape changes and it will act as a scramjet engine. There is one peculiar, you can say, disadvantage or peculiar feature of this. How you will start these engines? This engine need air to come in at a very high speeds. At ground level, how you start this engine? Ground level means it is not having this high speed, it will be low speed. Usual aircraft, it will go slowly, then it will pick up. So it will only works at very high speeds. The whole technology is only going to work at extremely high speeds. Initially, to reach that high speed, you will need totally different kind of technologies, like normal and propulsion technologies, normal aircraft technology. You have to install with this also, because this will only start working at once this aircraft is going at very high speeds or Mach 3 or that kind of speeds. To take this aircraft to that much speed, you need all these normal propulsion systems or normal propulsion engines. That is one of the disadvantage of Scramjet engine or Ramjet engine. Go ahead. Anything else? Just you can read out. No, everywhere it is being under test missions only. Commercial missions using this have not been so far successful. But even though it is called as test missions, the level of technology is at very high stage. In near future itself, we might see commercialization or much greater usage of these technologies. Now come to sounding rockets. We have seen some news like this. Honorable former Prime Minister Sri Ramnath Kovind witnessed 200th successive launch of RH-200, which is a sounding rocket. What is sounding rocket?
These are devices to study atmosphere, vertical horizontal.
Exactly. These are specialized rockets. It will not have XYZ, like it doesn't have the ability to put satellites and all. That is not the purpose of this. These are being only sent to take the measurements, take pictures, take what is the temperature ranges of XYZ, to take measurements and perform scientific experiments in upper atmosphere or even space. These kind of rockets are called sounding rockets. And it is mostly single stage rocket with all single stage means what will be the fuel? It is only solid stage propulsion. Most of this sounding rocket is having only solid stage propulsion. They are launched vertically. Altitudes it can be 50 kilometer to 1500 kilometer it can go. These are some examples of sounding rockets. RH-500 or Rohini RH-200. Like different heights it will go, then different names are given to it. So yeah, that's it about sounding rockets. You should know what kind of application it is being used to. Rest you can read out from here. Go ahead. So Vikram S. This has been recently in news. What is Vikram S? Tell me. So far, all the launches, all the rocket satellites are being launched by, satellites has been designed by XYZ, but all launches are done by ISRO only in India. So this is the first private launch in India, Vikram S rocket. You can see the ISRO picture here. It has been done by a startup company called Skyroot Aerospace. The specialized program for this is called Praramp mission. Hyderabad-based startup design launched 3 payloads onto suborbital mission known as Praramp. Okay. What is this suborbital launch vehicle means? Think more. What is suborbital launch vehicle? This Vikram S is called a suborbital launch vehicle. What does it mean? Suppose Earth is there, you need to put XYZ satellite into orbit. If it has to go in orbit, what is the requirement? It has to have certain height so that atmospheric drag will not act on it too much. Then it need to have to be put in certain velocity. It is only when we put this satellite at exact this velocity, it will stay in the same orbit throughout its lifetime. So this satellite doesn't have the ability to put these satellites at this much height or this much velocity. It will be acting only at small heights for now. Only 50 kilometers something is the range of this Vikram S satellite. It is a private satellite. Important thing you have to notice, this is the first total private launch in India. So this is all about launch vehicles. We have discussed PSLV, GSLV, LMV3, then what? SSLV, then sounding rockets, and Vikram has some other recent developments associated with these launchers. In the next part, we will discuss different types of satellite orbits, like geosynchronous orbit, sun synchronous orbit. We already discussed something about it in detail. What are the applications? What are the satellites launched into this orbit? What are the characteristics of this? This we'll discuss in the next class. So thank you for right now.